So I want you to do something for me right now. It's a small thing,
Yeah.
but it really sets the stage for everything we're about to get into today.
I think I know where you're going with this.
Yeah, probably. So grab your smartphone or, just look at your laptop if you're working.
The black rectangles we stare at all day.
Exactly. We spend half our lives staring at these things, scrolling, tapping, working, but we rarely stop to actually think about the hierarchy inside them.
Right.
Like if you can metaphorically crack that device open, peel back the glass, the battery, the circuit board, and look at the absolute bottom layer of the brain, the chip itself, what do you actually see?
Usually, you see a landlord.
A landlord. That is
Yeah.
a very, very specific way to put it.
But it's accurate, right?
Yeah.
You see an architecture that is entirely owned by a massive incumbent.
Like Intel.
Like Intel, or increasingly ARM. They own what's called the instruction set architecture.
AI.
The ISA, yeah. Which is basically the fundamental vocabulary the chip uses to think. And if you're a manufacturer and you want to use that vocabulary to build a chip, you pay rent,
Right.
you pay licensing fees, you pay royalties, and you play by their rules. It's a walled garden, a $1 trillion walled garden.
But, and I guess this is why we're here today, there's a crack in that wall now. A pretty significant one.
A massive one. We are talking about RISC-V, pronounced RISC-V, by the way.
RISC-V, right. And usually, if we were doing a deep dive on RISC-V, this would be a super heavy tech analysis.
Oh, yeah, we'd be geeking out over clock cycles and silicon wafers and benchmarks.
Right, but the source material we have in front of us today is, well, it's different. It's not a technical manual at all.
Not even close.
It reads more like a revolutionary manifesto.
It really does. The document is titled the RISC-V model, but surprisingly, it's not actually arguing about computer chips. It's arguing that the structure of how RISC-V was built, the very specific way it organized human effort, is a blueprint. A blueprint that we should copy-paste onto the entire global economy.
Which is a massive pivot. I mean, we are going from how do we design a processor without paying royalties to how do we build a civilization where the bottom 25% of earners actually own the means of production.
Exactly. The core premise here is that RISC-V did the impossible.
Yeah.
It proved that a bunch of academics, hobbyists, open source contributors could build a standard that actually outcompetes those trillion-dollar monopolies we just mentioned.
And the author is essentially asking, if that model works for the brains of our computers, why can't it work for the body of our economy?
Exactly. Why can't we apply it to robotics, housing, agriculture, education?
And so that is the mission of this deep dive today. We are going to explore this proposal for a, quote, parallel economy.
Which sounds totally utopian.
It does. It sounds maybe a little crazy at first glance. But when you actually look at the mechanics the source lays out, it's unsettlingly logical.
It's strictly logical. That's what makes it so fascinating. It's not based on wishful thinking. It's based on hard engineering principles.
Okay, so before we try to, fix the entire global economy, we really need to understand the tool we're using.
Right, the foundation.
Why RISC-V? Why is this the chosen analogy? Like, what makes it different from just saying, let's make things open source?
To understand that, you have to look at what the source calls the mechanical primitives.
Yeah.
What made RISC-V succeed where so many other open hardware projects just failed? The document lists 5 specific traits that, when combined, create this liberation machine, basically.
Let's unpack these. What is the first one? Like, what's the bedrock here?
The first, and honestly the foundation of everything else, is that it is open and royalty-free.
Meaning no toll booth.
No toll booth. And crucially, no mother may I.
Ah, okay, explain that.
In the traditional chip world, if you want to modify an ARM chip for a very specific task, say a specialized sensor for weather satellite, you often just can't.
Or you have to negotiate a massive corporate deal.
Exactly. Millions of dollars, years of lawyers. With RISC-V, the instruction set is in the commons. You don't have to ask permission from a CEO in Silicon Valley to innovate.
Which lowers the barrier to entry to basically zero. So if I'm a student in a dorm room or a startup in Nairobi, I can just start building immediately.
Correct. Which leads directly to the second trait, academic origin.
This feels like vital context.
It is. RISC-V wasn't built by a corporation trying to trap you in their ecosystem. It was born at UC Berkeley.
Right, go Bears.
It was designed as a public good for research. The incentives from day one were pure. They weren't trying to capture value or lock you in. They were just trying to create a standard that was clean, simple, and teachable.
So it didn't carry the what do you call it, technical debt of a company trying to protect its old patents.
Yes. Or forcing you to buy their specific proprietary hardware. It was a clean slate.
And because it was open and academic, you get the third point, right?
Crowdsourced global development.
Right, because it wasn't just Berkeley engineers working on it for long.
Suddenly you had the Indian government, tech giants like Google and NVIDIA, startups, universities all over the world, all pouring their R&D into the exact same bucket.
It's like it's the potluck dinner versus the restaurant menu.
Okay, I like that.
In a restaurant, you eat what the chef cooks and you pay the owner. In a potluck, if 100 people bring their absolute best dish, the spread is undeniable.
And you don't pay the restaurant owner. That is a very apt analogy. And that leads to the fourth primitive, which is hardware independence.
Meaning it's not tied to one factory.
Right. RISC-V isn't tied to one foundry or one brand. It's a universal standard. If one supplier suddenly jacks up their prices, or if a geopolitical conflict cuts off a supply chain...
You just take your design and go elsewhere.
Exactly. You aren't vendor locked.
That seems incredibly relevant given the state of the world right now. Supply chain resilience.
Resilience is built in from the ground up. And finally, the most powerful one, compounding improvement.
The magic of open source.
Right. If I figure out a way to make the chip process math 10% faster, and I publish that back to the standard, everyone else's chips get 10% faster overnight.
Versus a closed system where I hide that invention to just crush my competitors.
Precisely. The source argues that these 5 elements, when you combine them, create an innovation engine that moves faster than any single corporation can ever keep up with. It creates an ecosystem that learns.
Okay, so we have the liberation template. We have a way to build a brain without a landlord.
Yes.
Now, here is where the source material takes this massive leap. It wants to map those 5 points onto the real physical world.
The grand analogy.
The grand analogy. The civilization flywheel. Let's break this down because the document actually provides a translation table. It takes the chip concepts and translates them directly into economic concepts.
It does. So let's start with academic origin. In the chip world, that was professors designing an instruction set. In this proposed civilization model, that becomes a public think tank.
Now, when people hear think tank, they usually think of people in DC suits writing policy papers that absolutely no one reads.
Right. This is very different. The source describes a crowd-funded research engine driven entirely by prizes.
Prizes? Like bounties?
Basically, instead of private R&D labs locked behind corporate doors, you have a system that says, here is a $5 million prize for the first team to design an open-source modular tractor that costs under $5,000 to build.
And the key is, whoever wins that prize doesn't get to patent the tractor.
That's the royalty-free standard mapping. In RISC-V, the code is free. In this economy, the blueprint is free. The source calls this a public IP fund.
See, this is the sticking point for a lot of modern economics. Usually the argument is, if you can't patent it, why would you even invent it?
That is the trillion-dollar question. But the source argues that the IP capture model, where I invent something and then I charge rent on it for 20 years, is actually strangling civilization.
Because it creates wage dependency.
Exactly. It forces people to work for the owners of the IP just to afford the products made by that IP. It's a rent-seeking model at its core.
So this new model flips it. The inventors get paid the prize money up front.
They are compensated extremely well, usually far better than they would be by a standard corporate salary, but the result belongs to the commons.
So if I'm a member of this parallel economy, I essentially own the design for that tractor.
Yes.
I can download it, 3D print the parts, or hire a local machine shop to build it without paying a dime in licensing.
You own the means of production because the knowledge of how to produce is no longer a trade secret. It's a public utility, like water or roads.
Okay, let's look at hardware independence. In chips, that meant I could swap Intel for Samsung. What does that mean for the actual economy?
Industry and geography independence. The source is very specific here. The systems, the robots, the factories, the software, they must be platform agnostic.
So they shouldn't rely on a specific proprietary cloud, like AWS.
Or a specific country's supply chain. It's modular.
It's essentially civilizational prepper logic, but optimistic.
Yeah.
Like it works in a high-tech city, but it also works in a rural village with spotty internet.
Exactly. If the internet goes down, the factory just keeps running locally. If a trade war starts, you source parts from the town over, and that leads to the flywheel.
Okay.
In chips, we have Moore's law, right? Computing power doubles every 2 years.
Sure.
The source argues that if we strip away the IP laws and the trade secrets, we could actually see a Moore's law for the standard of living.
That's a bold claim. Moore's law applied to actual quality of life.
It is bold, but think about the logic behind it. If you improve the robot that builds the housing, housing gets cheaper. If you improve the solar panel that powers that robot, energy gets cheaper.
And if those improvements are instantly shared globally, with no patents blocking them,
The cost of living should theoretically collapse toward the bare cost of raw materials.
it sounds incredible. But I have to play the skeptic here for a minute.
Please do.
We're talking about open standards and IP funds. It's all very abstract. You can't live inside a PDF blueprint.
No, you can't.
You need actual walls. You need food, heat. You need atoms, not just bits.
You are absolutely right. And the source anticipates this entirely. It moves from the legal structure to the physical structure. It calls for a universal robotics control stack.
They call it the open ISA for matter.
That's the phrase. Just as RISC-V is an instruction set architecture for computing, we need an ISA for moving physical matter around.
This is where we get into the nuts and bolts. What does a universal manufacturing OS actually look like?
The source gets pretty deep into the weeds here with things like URDF, Unified Robot Description Format, and Universal Kinematics.
Okay, simplify that for us. What is universal kinematics?
Kinematics is just the math of motion. It's how you tell a machine, move your arm 30 degrees to the left.
Right.
But right now, a KUKA robot speaks a completely different language than a FANUC robot, which is different from a MakerBot 3D printer. They are all silos.
They don't talk to each other.
Exactly. So the source proposes a standardized math layer where any machine can understand any instruction.
So it's like the USB standard, but for factory motion.
Yes. Imagine if you had a 3D printer, a CNC mill, and a robotic arm, and they all ran on the exact same operating system.
Okay.
You could just download a file for a toaster, and the system would automatically figure out which machine does what. The CNC cuts the metal, the printer makes the plastic handle, the arm assembles it.
And self-calibration is mentioned too. Why is that piece so important?
Because currently, setting up a factory requires expensive experts. It takes weeks of tweaking. If the robots can self-calibrate, if they can just wake up, look around, and figure out where they are and what tools they have attached.
That you don't need a master's degree in engineering to run a microfactory.
Exactly. It democratizes manufacturing entirely. It takes the expert out of the loop for the basic setup.
And I guess that enables that compounding improvement again. Like if someone in Brazil figures out a better line of code for grasping a slippery object,
They push that update to the stack. And suddenly, every single robot in the ecosystem, whether it's picking apples in Washington State or sorting recycling in Tokyo, gets better at grabbing things instantly.
with no proprietary wall stopping the upgrade, no version 2.0 hardware that you're forced to buy.
Exactly. It turns the entire global manufacturing base into one giant unified learning machine.
Wow. Okay, I want to pivot to something else that really caught my eye in the source material.
Okay.
We've talked about the robots, we've talked about the laws, but what about the people? Specifically the learner persona we always talk about on this show. If you're going to run a totally new economy, you need people who actually understand how to run it.
Yes. The source has a whole section on rewiring education, and frankly, it is the most radical part of the proposal.
Radical is definitely one word for it. It proposes an entire educational stack.
It does. The argument is that our current education system is designed for the old economy. It's designed to create employees who sit at desks, follow instructions, and consume information.
Right, factory model education.
Exactly. The source argues that if we want people to run a decentralized, highly automated economy, we literally need to upgrade the human software.
And the tools they list are very specific. It's not just teach more math. It's logic plus linguistics plus Lodgebond.
Lodgebond, yes.
For those who haven't spent time in the deep, nerdy corners of internet linguistics forums, Lodgebond is a constructed language, right?
It is. It was designed back in the late 80s based strictly on predicate logic. The entire goal was to create a language with zero ambiguity.
Zero ambiguity, so no puns, no double meanings.
No cultural baggage. A word means exactly what it means. The fact that the source explicitly lists Lodgebond suggests they believe standard human language, English, Spanish, Mandarin, is just too messy for precise economic coordination.
They want students to literally think in code.
They want students to think in pure logic. If you are interacting with that universal robotics stack we just talked about, ambiguity is a fatal bug. You need absolute precision. If you tell a robot to move over there, it crashes. You have to define move over and there in absolute logical terms.
It gets weirder, though. The source also lists tech integration using AR and EEG.
EEG, adaptive learning.
Brainwave monitoring in the classroom. I mean, that sounds intense.
It sounds incredibly dystopian if you frame it as surveillance, but the source frames it strictly as optimization.
Optimization of learning.
Right. The system monitors your brain activity to see if you are confused, if you're bored, or if you are in a flow state, and then it adjusts the curriculum in real time to keep you in that sweet spot of maximum learning.
It's hyper-efficiency. It's treating the human brain like another processor that can be optimized on the network.
And the goal isn't just learning for the sake of learning. The source draws a hard line between consumption and production.
Okay, unpack that.
Today, students consume facts. In this model, students contribute to the IP commons from day one.
So a fifth grader isn't just solving a random math problem on a worksheet that gets thrown in the trash.
No. They might be designing a simple gear or optimizing a line of code that actually gets reviewed and used in the global stack.
It turns the entire education sector into a productive industrial engine. You learn by building the actual civilization you are going to live in.
It dissolves the line between student and worker entirely.
Okay, we have to talk about the elephant in the room here.
The money.
The money. This all sounds incredibly expensive. High-tech robots, brain-scanning EEG headsets, global think tanks handing out $5 million prizes. We clearly aren't going to venture capitalists for this.
No, VC funding would defeat the whole purpose of open ownership.
And we aren't waiting for government taxes to fund it either, so who pays?
The economic substrate. The source proposes a massive crowdfunding mechanism, but not like a Kickstarter where you buy a cooler or a smartwatch. This is an investment model.
It mentions a very specific number of people.
100 million people.
100 million. That is a small nation.
It's massive. But the structure relies on microfunding. The source suggests starting with just $1 a month.
$1.
Then slowly scaling up to $2, then $5, and capping out at around $25 a month.
The logic being, you don't need a benevolent billionaire if you have 100 million people pitching in the price of a couple cups of coffee. Let's do the math. 100 million people at $25 a month. That's $2.5 billion a month.
It's a NASA-level R&D budget every single month.
That easily rivals major corporations.
It surpasses most of them. And that money funds the public think tank and all those prize purses we talked about.
Yeah.
It creates a self-funding industrial ecosystem. But here is the truly critical part. The ownership.
Right. Who actually owns the output of all this?
The source is very specific here, too. The long-term goal is for this parallel economy to be owned entirely by the bottom 25% of earners.
Why that specific demographic?
Because the top earners already own the current economy. They own the stocks, the land, the IP. Automation historically always benefits the owners of the machines, not the workers.
Yeah.
If you just create more jobs, you aren't solving the wealth gap. Because wage earners don't capture the compounding value of the automation, the owners do.
So this project is attempting to build a counterbalance to that.
Yes. It's a massive asset ownership play. The core argument is, don't demand higher wages, build your own machine.
Wow.
If the bottom 25% collectively funds and owns the IP and the robots, then as the flywheel spins, as the robots get better and production gets cheaper, all that value accrues directly to them.
It's a way to permanently break the cycle of wage dependency. You aren't asking a massive corporation for a job. You are literally co-owning the factory that makes the things you need.
Correct. It's about securing a stake in the automated future. The source argues pretty bluntly that if you don't own the robots, you will be replaced by them. But if you do own them, their productivity liberates you.
It really is the final compression, as the source calls it, taking the technical success of a silicon chip architecture and trying to expand it to the entire human experience.
The summary is effectively this. RISC-V proved that an open, royalty-free standard created by academics and improved by a global community can outcompete trillion-dollar incumbents.
Right.
This project is simply attempting to copy-paste that exact logic onto farms, housing, and logistics.
It's the ultimate so what of the century. If this theory holds, it means we've been building civilization wrong, or at least highly inefficiently.
It suggests that the only way to build a system that truly serves the public is to build it like a public utility, from the code up.
You can't regulate your way to equality.
You cannot tax your way there either. You have to build a totally new operating system that bypasses proprietary lock-in completely.
It's a parallel path. You don't tear down the old factory, you just build a new, infinitely more efficient one across the street and invite everyone to work there.
And own it.
And own it. That is the key difference. You know, as we wrap up this deep dive, I keep thinking about that education piece.
The lodge bond stuff.
The lodge bond and the EEG headsets. It's honestly the most provocative part of the source for me.
Why is that?
We're talking about changing the operating system of our economy, right? How we buy, make, and own physical things. But the source seems to subtly suggest that isn't going to be enough.
How so?
Well, by including things like constructed logical languages and brain adaptive learning as standard required tools, the source is implying that our current software, our actual brains, our messy languages, our distracted minds, just isn't capable of running this new civilization.
That is a profound observation. It implies humans are the bottleneck.
Exactly. It suggests that to upgrade our civilization to this pure, logical, open-source model, we might also need to fundamentally upgrade ourselves. We might need to change the operating system of our own minds to even be compatible with this new level of coordination.
A thought to leave you with as you look back at that smartphone we started with?
Right. It runs on a chip. But what runs you?
A question definitely worth asking.
Thanks for joining us on the Deep Dive today. Take a look at the standards in your own life. Are they open or are you locked in? We'll catch you next time.